The structural failure report arrived at Overseer Thress-Varun's desk at the same moment. She was signing off on the third certified remediation plan in 6 months. She set down her stylus without reading it. She already knew what it said. Deck 7 of the Korvath Fabrication Hub had cracked again, same load-bearing joint, same torsional resonance signature, same catastrophic failure mode that had swallowed 12 hours of production time, 3 engineering teams, and more certification fees than she cared to tabulate. The joint had been modeled by the foremost algorithmic design suite in the compact, rebuilt twice to exact specification, load tested to 140% of rated tolerance, and had still fractured under operating conditions like it was making a point. Thress-Varun was reptilian, scaled in pale amber green from her angular jaw to the tips of her broad fingers, and she had been overseer of structural integrity at Korvath Hub for 11 years. In 11 years, nothing had beaten her 3 times in the same location. This was a professional offense. She pressed the report flat with one palm and called up the engineering review queue. 22 open submissions waited. Most were from her certified contractors, Werk-class algorithm firms with full compact accreditation. She began scrolling through their updated proposals, each one denser and more mathematically exhaustive than the last, each one diagnosing a different root cause, each one backed by simulation suites that had never been wrong before and were apparently wrong now. She reached the bottom of the queue. There, filed 3 days ago and flagged with a yellow caution tag, meaning it lacked accreditation, was a submission from the station's human exchange placement. Name: Senna Okafor. Role: Structural Observation Intern, 6-week placement, Compact Exchange Program. Her submission title read, Harmonic Node Analysis, Deck 7 Joint Cluster Manual Survey. Thress-Varun's eyes paused on it. Manual survey. The human had hand-drawn something. She almost scrolled past. The caution tag existed precisely for submissions like this: helpful intent, insufficient methodology. But the queue was 22 deep, and she had already read 17 variations of the same algorithmic disagreement, and something in the flat simplicity of the title made her open it. The submission was 9 pages. The first page was a hand-drawn diagram. Not a scan of a model, not a rendered cross-section from a certified tool. An actual ink diagram drawn on grid paper, the kind that human exchange students apparently carried in physical notebooks. The lines were clean and confident structural annotation in neat lettering, load vectors marked with arrows, joint geometries rendered by hand to a precision that was, Thress-Varun had to admit, surprisingly readable. The human had sketched Deck 7's entire joint cluster from memory, or from direct observation, and had annotated it with a system of numbers she didn't immediately recognize. She read page 2. Senna Okafor had spent 3 weeks conducting what she described as a manual resonance walk, moving through Deck 7 during and after operating cycles, placing a calibrated contact sensor on structural members, and recording frequency readings by hand. She had logged every reading in a notebook. She had then plotted the readings spatially on her hand-drawn diagram and identified what she called a harmonic node, a point where the natural vibration frequencies of 2 adjacent structural members arrived in phase and amplified each other, producing a cyclical stress concentration that no static load model would ever detect because it only existed under dynamic operating conditions. The joint that kept failing sat exactly on that node. Thress-Varun read the sentence again. Then she turned to page 3, which was 43 rows of handwritten frequency data, time-stamped in a grid. Her certified contractors had run 17 algorithmic analyses. None of them had done a resonance walk. None of them had taken contact sensor readings under live operating conditions. The algorithmic suites were designed to model static geometry and material properties. They were exceptional at both, but Senna Okafor had identified something that no static model could find: because the problem did not exist in the geometry. It existed in the timing. The human had written, in the summary on page 7, the node point shifts by approximately 3.2 centimeters depending on operating load, which means the certified repair each time has been applied to the right location at the wrong moment. The underlying frequency mismatch hasn't been addressed. It won't go away until the natural frequency of one of the two members is changed. She had then sketched on page 8 3 proposed interventions, each one a simple modification to the mass distribution of one structural member, each one annotated with an estimated cost and a predicted change to the resonance frequency. The most conservative option required adding a collar of dense material to a 14-centimeter section of one load member. Cost: minimal. Installation time: 2 hours. Predicted outcome: harmonic node eliminated, stress concentration resolved. Thress-Varun sat back in her chair. She thought about the 3 certified firms whose combined modeling hours now exceeded the annual budget of a small orbital station. She thought about the crack reports. She thought about the fact that a 22-year-old human on a 6-week observation placement had walked Deck 7 with a contact sensor and a notebook, and had apparently identified the thing that all of them had missed. She pulled up Senna Okafor's placement file. The photograph showed a young woman, dark-skinned, hair pulled back, standing in what appeared to be an engineering bay on one of the human stations. She was holding what might have been a wrench and squinting thoughtfully at something off-frame. Her file noted that she was in her final year of a structural dynamics program at a human institution called the Lagos Technical Institute, that her exchange placement had been arranged through the compact's standard engineering observation track, and that her assigned duties were observation only. She was not credentialed for structural modification recommendations. The last line of her duties section said, "No design authority, observation and reporting role only." Thress-Varun made a decision. She sent a message to Deck 7 shift supervisor requesting that the human intern be available for a review meeting that afternoon. Then she sent a second message to the senior partner at Verk Algorithmic Design, the most expensive of the 3 certified firms, requesting his attendance at the same meeting. She did not explain why. The meeting took place in the Deck 3 review room, a narrow space with a long table and a wall-mounted display. Senna Okafor arrived first, carrying a notebook and a small hard case. She was shorter than Thress-Varun had expected, wearing the plain gray coverall of the exchange program with a yellow observation badge clipped to the front. She sat down without ceremony, placed her notebook on the table, and waited. Thress-Varun arrived next and sat at the head of the table. She did not speak immediately, because the senior partner from Verk Design, a scaled engineer named Dath Coral, arrived a moment later with a data pad and a look of prepared confidence. He had clearly assumed this was a follow-up meeting about his latest proposal. He glanced at Senna Okafor, noted the yellow observation badge, and returned his attention to Thress-Varun. "I've prepared a summary of the Phase 3 remediation specifications," he said, setting his data pad on the table. "The modeling suite has been updated with the latest material stress data, and I believe we've isolated the—" "I've read it," Thress-Varun said. She laid Senna Okafor's 9-page submission on the table, the hand-drawn diagram on top. "I'd like to hear your assessment of this first." Dath Coral looked at the diagram. He picked it up. He turned it once, then again, reading the annotations. His expression did not change, but his next breath came slightly slower than the one before it. He was the kind of engineer who understood immediately when something was either very wrong or very right. A quality Thress-Varun had hired him for, and that quality was now working against him in a way he had not anticipated. "This is a manual survey," he said. "Yes. The methodology isn't certified. Contact sensor readings taken by hand without a calibrated algorithmic cross-reference can't." "The frequency data is in the appendix," Thress-Varun said. 43 readings, time-stamped over 3 weeks, charted spatially. The node point is consistent across all readings. The joint failure locations align with the node position to within 4 centimeters. She paused. Your 3 proposals have a combined simulation runtime of over 9,000 hours. How many contact sensor readings under live operating conditions are included in that dataset? Dath Coral's jaw did not drop. He was too composed for that. But his eyes moved from the diagram to the submission summary, and then to Senna Okafor, who had not said anything yet and showed no particular interest in saying anything now. She was watching the table. The algorithmic model accounts for. It accounts for static loading, Thress-Varun said. It does not account for dynamic resonance. The submission does. Silence moved through the room with the careful deliberateness of something that knows it cannot be recalled. Dath Coral set the diagram down. He pulled up his data pad and scrolled to a section of his latest proposal. He was, Thress-Varun could see, already running calculations, checking the resonance frequencies of the 2 structural members against the hand-drawn annotation, seeing whether the numbers aligned. They did. She could tell by the slight tightening around his eyes. The collar modification is within fabrication parameters, he said at last. The words came out with the particular flatness of a sentence that has lost its intended meaning somewhere in transit. It's a viable intervention. It is, Thress-Varun said. She turned to Senna Okafor. Walk me through the node calculation. Senna Okafor opened her notebook to a page near the back. She placed it on the table so both of them could read it. Then she walked through the frequency analysis in exactly the same tone she might have used to describe a lunch order, clear, unhurried, specific about the numbers, pausing twice to point at her hand-drawn diagram when the spatial relationship mattered. She did not look at Dath Coral when she spoke. She did not appear to need anyone in the room to understand that she was correct. She simply explained it, the way someone explains a thing they have already verified. When she finished, Thress-Varun asked 2 technical questions. Senna Okafor answered both, one of them by flipping to a page of calculations at the front of the notebook and pointing at a specific line. Dath Coral asked nothing. Thress-Varun authorized the collar modification that evening. She assigned it to her in-house fabrication crew, a 2-hour job, and requested that Senna Okafor observe the installation and take post-installation frequency readings. The fabrication lead, a broad-shouldered veteran named Korvath Fabrication, had looked at the hand-drawn specification with the expression of someone reading an instruction left in a dead language, but he had cut the collar to spec without comment and fitted it to the load member exactly as the sketch described. The installation was completed before the next operating cycle began. The readings came back the following morning. Senna Okafor delivered them in a single-page summary with a new hand-drawn diagram showing the node point's behavior under operating load. The node had moved. The 2 resonance frequencies, which had been meeting in phase at the joint cluster for 6 months, were now arriving out of phase. The stress concentration had dropped by 81%. The joint cluster ran through 3 full operating cycles without incident. Thress-Varun read the summary standing at her desk, and she had a thought that she turned over carefully before deciding it was accurate. 9 certified algorithmic firms working across 11 years of her tenure had never once brought her a resonance walk. They had brought her models. They had brought her simulations. They had brought her reports whose level of mathematical complexity made them difficult to challenge even when they were wrong, which was a form of insulation she had, to her professional embarrassment, occasionally relied upon. A 22-year-old human with a notebook and a contact sensor had spent 3 weeks walking the same deck and had written down what she found. She filed a formal commendation for Senna Okafor with the Compact Exchange Program Office. In the notes section, she wrote, Applicant identified a dynamic resonance failure mode through direct physical observation that went undetected by 3 certified design firms across 6 months and multiple analytical cycles. Recommendation: full engineering exchange credit and consideration for advanced placement track. She considered whether to copy Dath Coral on the message. He had, to his credit, said nothing further after the meeting, and had submitted a revised analysis 2 days later that incorporated the resonance walk methodology, noting in the cover letter that his firm would be adding dynamic frequency observation to its standard assessment protocol going forward. It was, she thought, the most expensive lesson in his firm's history. She did not copy him. The Deck 7 joint cluster ran without incident for the next 4 weeks, and then for the 4 weeks after that, and at no point during those weeks did Thress-Varun feel the need to read another algorithmic failure report. She did, however, find herself thinking about the frequency data in Senna Okafor's notebook, 43 readings, each one taken by hand in a live operating environment, each one meaning something only in relation to the others and to the space they mapped, and wondering, with the particular discomfort of a professional who has just learned something from an unexpected direction, whether there were other places in Korvath Hub where something was vibrating and no algorithm had noticed. She pulled up the exchange placement roster for the next quarter. There was one more human intern in the structural observation track. She added a note to the placement file: encourage direct observation methodology. Provide access to decks 2 through 9. The note took her less than a minute to write. She sent it and returned to the failure reports, which were shorter now, and which she was beginning to read differently.